perfectly okay. Just a minute. Over. Over. Just setting it. Little smaller in me. Let me see, that's all not. No, it's smaller. I think now okay. Not. No, not right. Oh, yes, now we can manage. Just 1 minute. Yeah, so quality. Is the full board visible? 1 minute. I'll slightly turn it down. Bring it little down. No. Slightly out. Slightly reduce it. The adjustment is killing me. No, now okay. No, still little smaller. Sometimes it's playing with me. Okay. Now I will not go for further. Sufficient. If something is visible, little this side. Okay. Better not go for further adjustment. Couple visible. Full visible. If I go to further adjustment, it will take time. The voice is clear and the board is fully visible. Both okay. Voice and screen, both are okay. Voice and screen, both are okay. Fast. Voice and screen, both are okay. Okay, right. I will start now. 1 minute. See, first I will give the question for you. I told you I am reversing the cantilever, and see, Momentarian calculation I already wrote. I will explain it so that you can tell now onwards. Any question on Momentarian, if you solve, you can solve by conjugate beam method. Okay, start. I will put question here. A cantilever beam of length 3 meter. 3 I have not written here because my splitting is there. Space is not there. Is of length 3 meter. And important, it is fixed at the right end, not left end. Then it has got an anti-clockwise couple of 60 kN meter at the left end. That is A. Anti-clockwise couple. And then a point load of 30 kilonewton at the free end left end. And UDL of 50 kN per meter for 1.8 meter from fixed end, right end. Or still easier, question can be given what? For the beam shown in figure, that is the best one. For the beam shown in figure, question is find what? Theta max and y max, slope and maximum deflection, and also slope and deflection at the point C or at the left end of the UDL. Okay, this is a question. Okay, start. Now, what we will do is, before you start Momentarian, And before you start conjugate beam method, time is there. We will first go for shortcut. See, shortcut. Correctly understand now. This is long back, very thoroughly explained. How to do shortcut by cutting all, I told very clearly. Therefore, see, what you can do is correctly calculate one by one. See, first you calculate, see, theta max is nothing but theta at the free end. Free end. That is at which point? At A. And y max is y at free end. That is at A. Last time it was B because B was free end. See the elastic curve here. Now elastic curve will come like this. So maximum slope and maximum deflection both are at the free end here A. Okay, now first to concentrate on finding theta, which one? Theta max means theta A, y max means ya. Okay, see correctly. See here, if I put a cantilever here, I am solving by shortcut method. No method, own direct formula. There is a couple here of 60 kilonewton meter. For that, beam will bend like this. If you remember, this deflection and this slope, formulas are there. This is ml square by what? 2ei. Slope is ml by ei, if you remember. Tell the answer first. See, the direction is, slope is anti-clockwise, deflection is down. Answer, m. 60 into full span is 3 meter. 60 into 3 square by 2 ei equal to, this is 60 into 3 by ei. This is 180 by ei. How much this one? 60 into 3 square by 2. What is the answer? 60 into 3 square by 2. Answer. 60 into 3 square by 2. That is the maximum deflection. Little fast. I will first finish a shortcut. 270. Don't make mistake. 270 by ei. Correct? 270 by ei. Okay. Leave it now. Now, side by side, consider that point load. Point load is here. How much load? 30 kilonewton. Span 3 meter. Elastic curve goes this way. This deflection is WL cube by 3EI. This slope is WL square by 2EI. So if you use that property, calculate by substituting. W, how much W? W is 60 into 3 cube by 3EI. This is 60 into 3 square by 2EI. What is the answer? Tell first this one. 60 into 3 square by 2EI. 60 into, not 60, sorry. Load is 30. 30. 30 is the load. 30 into 3 square by 2EI. Tell this answer. 30 into 3 square by 2EI. Answer. Don't make any mistake. First tell me 30 into 3 square by 2EI. How much? This answer first. Do not delay. Little fast you tell. 30 into 3 square by 2EI. In case you make a mistake, later result will not tally. 135 by EI. Don't give wrong values. 135 by EI. And this one, 30 into 3 cube by 3EI. 30 into 3 cube by 3EI. What is the answer? 30 into 3 cube by EI. 270 by EI. Okay. Now, next. Now consider, see, we are finding slope and deflection at the free end. Cantilever with the UDL up to here. Oh, problem. Why? No. This length is 1.8 meter. This length is what? 1.2 meter. If you remember, elastic curve will go this way. This way. Then, no, not that way. How it will come? It will have curvature up to here. Then straight line. Then, these slopes are equal. And this deflection required. This slope is cantilever of length 1.8 meter. How much it is? WL cube by 6 EI, your L is 1.8 meter. Tell the answer. How much UDL? UDL is 50 kN per meter. 50 into 1.8 cube by 6 EI. Tell the slope. 50 into 1.8 cube by 6 EI. That is the slope at this point. Same slope here also. 650 into 1.8 cube by 6 EI. Delaying a lot. Then you cannot. 486 by EI. No wrong value. And this deflection equal to what? WL power 4 by 8 EI. L is 1.8. 50 into 1.8 power 4 by 8 EI. Tell the answer. 50 into 1. See, if that is 486, this is also 486 only. 50 into 1.844 by 8. By chance, if any one value you give wrong, answer will not tally. Remember, I cannot once again come back here. I will tell something wrong when you gave the answer. That is the only thing I can tell. Later, when I do Momentarian method or conjugate beam method, in case answer is not tallying, I will do one thing. I will look at the problem, apply my trick and tell what is the answer. Then that means somewhere here there is a mistake. That is the only chance. This answer. 50 into 1.8 power 4 by 8. You are not giving answer. 50 into 1.8 power 4 by 8. Why this much delay? This 486 I got doubt. See, you made a major mistake. 48.6. Okay, see, this mistake would have spoiled everything now. Okay, now this answer. 65.61 by EI. Okay, now then this deflection equal to what? This deflection 65.61 plus this slope 48.6 into further distance of 1.2. Tell the answer. This is all I told you. Deflection here is because straight line. Whatever is this deflection plus whatever is slope there into this distance will give this deflection. Already. This deflection, it is 65.61. You should give full number. Should not give partial number. I want full number. 50 into 1.8 power 4. I'll calculate, is not on. 1.8 power 4. Okay. 123.93. Okay. This is 123.93. Therefore, if everything is correct for this question, your theta A, that is going to be theta max, is going to be, tell the answer, how much? 180 by EI plus 135 by EI plus 48.6. 180 plus 135 plus 48.6. 180 due to couple, 135 due to that point load, 48.6 due to UDL. See, slope at A, slope at A, slope at A. Add this one, 180, 135 and 48.6. Add all the three values. Add all the three values. 363.6. Correct ಆಗಿದೆಯಾ? ಒಂದು ನಂಬರ್ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ನೀವು. Okay. 363.6 should be the answer. I write here now. 363.6 by EI radian anti-clockwise. And deflection at A, that is your Y max, should be how much? Start. 270 by EI plus, once again 270. I don't know why it came same. 270 plus 270 plus 123.93. Are you sure it is correct? 270 and again 270 plus 123.93. How much? 663.93. That is 663.93 by EI meter down. This is the answer we are getting by shortcut method. Okay. Then later we want theta C and YC. We'll get that also. Sorry. Start. Suppose the question is an objective question, not theta A they want. They want theta C. Then I told you another trick for you. See, if you remember, I told a trick for you. If you remember, see, right now. Now, if you want slope and deflection here, you consider only cantilever from B up to what point? Up to C. Apply that UDL. How much? 50 kilonewton per meter. Length of cantilever is 1.8 meter. Then I told you one thing. This load should be transferred here. A point, see, from here it should transfer 30 kilonewton. And a couple will come. How much couple? It is anti-clockwise 60 and also anti-clockwise of 30 into 1.2. Can you answer? Anti-clockwise 60 and anti-clockwise of 30 into 1.2. How much answer? 60 plus 30 into 1.2. Couple. 60 and 30 into 1.6. That is the couple. See, I am taking a risk here. Later, if answer is not telling, anywhere mistake means I am not responsible. 96. Okay, now solve this question. Okay, now very simple. See, beam will bend like this. This slope equal to what? For couple, I will write formula ML by EI for couple plus WL square by 2EI for point load plus WL cube by 6EI for UDL. Therefore, slope is 96 into 1.8 plus 30 into 1.8 square by 2 plus 50 into 1.8 cube by 6. Tell the answer. EI I am not writing. EI I am not writing. Correctly is answer. 96 into 1.8, 30 into 1.8 square by 2 plus 50 into 1.8 cube by 6. Answer. This is a risk actually. Writing the answer before starting a method is the most dangerous thing. Why? If something does not tally, but I am not worried because why? Only chance is what? Calculation mistake. Technical mistake is not there. It answer 270 by EI. Correct. Okay. That will be equal to 270 by EI. No. ಆಮೇಲೆ ಗೊತ್ತಾಗತ್ತೆ ಯಾಕೋ ಡೌಟ್ ಇದೆ ನನಗೆ 270 ಯಾಕೋ ಡೌಟ್ ಬರ್ತಾ ಇದೆ ಓಕೆ ಇಲ್ಲಿ ಬಿಡಿ ಸಬ್ಜೆಕ್ಟ್ ಟು ವೆರಿಫಿಕೇಶನ್ ಲೇಟರ್ ಇಫ್ ಆನ್ಸರ್ ಈಸ್ ನಾಟ್ ಟ್ಯಾಲಿಂಗ್ anti clockwise I will tell these values answer given is wrong in the class I am correcting it now. And deflection, how much deflection? The deflection is, see, for couple ML square by 2EI, for point load WL cube by 3EI, plus for UDL WL power 4 by 8EI. Calculate M 96 into 1.8 square by 2 plus point load 30 into 1.8 cube by 3 plus UDL 50 into 1.8 power 4 by 8. This is going to be deflection here. This all I told you earlier, shortcut. If you want free end, what to do? If you want somewhere else, what to do? If you want somewhere else, from free end up to there, remove the loading, introduce force and couple and do like a normal cantilever for remaining length up to fixed end. This all told for you. Last answer. But anything is wrong means only chance is calculation. But I can't check once again. I will use my trick then. I will tell while doing this calculation you made a mistake, correct it, then that answer will come. 279.45. Okay. 279.45. That is the deflection later. 279.45. Okay. Downwards. Over. Now, shortcut method is over. This is meant only for those who came earlier for shortcut classes. Okay, now leave it. This is now my trick I will apply later. My trick I will apply only if the answer by momentary and conjugate beam. See, momentary conjugate beam answer has to tally. Why? Because same calculation I told you. Momentary conjugate there is no tallying, because whatever I write here, same will come here. So therefore no tallying. So now we are tallying the answer of momentary conjugate with trick. Suppose answer is not tallying, I will tell some calculation mistake is done here, correct it, what all I told, correct it, then you get. Then I will apply my trick. I have got a special trick now. I do not require this much. To get slope and deflection here and here, I need very less time. I got my own special tricks are there. Okay, leave it. Start. Now, I will first solve by Momentarian method. I will not rub everything. Then I will solve by conjugate here, one by one. Okay, start. Momentarian method. Write the beam once again. There is no time to write for me. All that what I gave, right here. Nodi. See, you write the question here once again. Write everything from there. 50 kN per meter, 30 kN and 60 kN meter, 1.8 AB. Draw bending moment diagram. Okay. Bending moment diagram you require for Momentarian method and also conjugate beam method. You can do one thing. For bending, see, right here, this is the BMD. BMD. Now, you write a note here. Bending moment diagram, I don't want to waste space. You write here, BMD for this beam, you have to write Momentarian method. You calculate with sign, but enter without sign. I told you. For that, you refer conjugate beam method. Start, come here. BMD for real beam. Remember, point load, couple and UDL. If I write the combined bending moment diagram, BMD will come, it will come this way. Okay. Then, can I divide into this? See, it will come this way. This curve, can I divide it like this? Rectangle and parabola. Can I divide that way? Tell me. Can I divide that way? Fast. You know, if I draw combined bending moment diagram, finally you get a curvature there. Can I divide into a rectangle and parabola? Fast. This I told earlier. Are you allowed to divide into a rectangle? No, it is nonsense. Therefore, if you want to use formula for that UDL bending moment diagram, what do you have to do? BMD for that UDL should be drawn separately. Make a note. When we draw BMD for UDL, we want to apply formula. In that case, you should draw BMD for the UDL separately. Therefore, right here. First BMD for real beam. There no real beam. Considering the couple and point load. Okay, I will do here now. See, I will consider the couple and point load. I will write here systematically. See, so that you write separately. A couple of 60 kilonewton meter and a point load of 30 kilonewton. Okay, this is, now UDL is not there. This is A and this is what? B. This is A and this is B. Oh, this is actually is the same line. 1 minute here. Okay, now start. I want bend. Look this free. Always look free hand side. See, bending moment. That is this calculation. Oh, there is no shear force is constant there. Oh, I thought point load is there. So it will be same line. Okay. It will be same line because, okay. Oh, that's same line because there is no change of shear force. I forgot. Okay. It is 150. Okay, start. Now, calculation. Bending moment at A. Look this side. No clockwise, anti-clockwise. Bending moment. Minus 60. Over. Then, bending moment at B. No other point. Equal to. Minus 60 minus 30 into 3. This is 3 meter. Minus 60 minus 30 into 3. Answer. minus 60 minus 30 into 3. At A BM is minus 60, at B BM is minus 60 minus 30 into 3. Minus 150. Okay, now, therefore, your BMD will be, see I write a BMD here, 60 here, it will go to how much? 150 here, 60 here and 150 here. Okay, now, next, now draw, so that is this diagram, minus, full minus. Okay, now, here sign required. Now BMD for real beam considering only UDL. One thing forgotten. Okay, 1 minute. One thing forgotten. See, it is down 30 and anti-clockwise of 60 here. So, see, here how BMD you got? Here you got minus 60. Here you got minus 150. It came this way. Now, later, when you want to BM at C, see, now, if later, see, suppose you want only slope and deflection at free end, maximum, then you don't have to consider divide into rectangle and triangle, correct? Divide into rectangle and triangle, clear or not? See, if your purpose is to find slope and deflection at A only, that is if the question is only to find maximum slope and deflection, make a note, divide into rectangle and triangle, clear? Clear. But later we want slope and deflection at C also. At that time we want once again this side. What to do? Therefore, tell what is this bending moment at what distance? Distance of 1.2 meter. Tell the bending moment here. So extra bending moment at C equal to, see here, minus 60 minus 30 into 1.2. Minus 60 minus 30 into 1.2. Answer. Minus 60 minus 30 into 1.2. Answer. Minus 60 minus 30 into 1.2 is minus 96. Okay. Minus 96. Okay. Therefore, if I write here dotted line, this is 96. This is the BMD for point load and couple. Okay, now BMD for real beam for UDL. Separate sketch I will write here, this way. How much UDL? 50 kilonewton per meter. This gap is 1.2 meter. This is 1.8 meter. This is A, this is B, this is C. Now see, BM at A equal to 0. Look this side. BM at C also equal to 0. BM at B equal to minus 50 into 1.8. 50 into 1.8 into 1.8 by 2. Tell that answer. 50 into 1.8 into 1.8 by 2. What is the answer? 50 into 1.8 into 1.8 by 2. Minus 81. So your BMD will be 0 here, 0 here, 81 here, and it will be what? It is not a straight line, it is a parabola of second degree. It is second degree parabola. 1 minute. When I want red color, I won't get it. It is a usual problem. If I want, I won't get. Illa. Just now I was having it. Where I kept it? Okay, it is a parabola of second degree, this way. Okay, now tell me, for this parabola, tell me, is the formula of area equal to 1/3 base into height and CG at 3/4 or 1/4 applicable or not applicable? Tell me. See here, for this parabola, area equal to 1/3 base into height and CG at 1/4 or 3/4 is applicable or not applicable? First. Is applicable or not applicable for this parabola? It is only due to UDL. Applicable. Therefore, make a note. Later, when you want area, see red color. For this parabola, area equal to 1/3 base into height and CG will be from here 3/4, from there 1/4. Okay, make a note. Okay, over. See, red color. Here also red color. Here also red color. Okay, over. Okay, now draw BMD. Okay, see, Momentarian method. These are the BMDs. I wrote BMD here. Now, come this side. Once again draw BMD so that you can fluently calculate slope and deflection at A and C. Since you want A and C, see now. See, this, if you want only full diagram, you can divide into a rectangle 60 and this side. But later, I want C to be separately. Again, one more division required. For that, what I will do is, see now, I will change this diagram for easy calculation. See here. I will change it here now. Once again. Here 60 here. A rectangle of 60. Then, tell me here. This is a triangle. Tell me, what is this side first? What is that height? Think it. See here. This bending moment is 96. This is 60. What is this ordinate? You should write. You should show the calculation yourself. That ordinate. How much? That ordinate. I am not writing in the class. You should write it. That ordinate. See, this full is 60. This full is 60. This is 96. If I divide like this, what is this ordinate? 36. Okay, 36. Now, then there is one more rectangle of how much? One more rectangle of constant. Tell this ordinate. How much? That ordinate. Actually, you can save the time by what? This much not required. If you want full, you can see only one rectangle and triangle. But since I want C point, I do not want to divide so many times. So one extra division, so that what? I can find A and C. Make a note. If your purpose is only A to B, this much not required. Directly a triangle 60 and 0 to that one. This is also what? 96. Then what is this ordinate? Total is 150. Total 150. What is this ordinate? That ordinate. Total 150. So that ordinate. Little fast. That ordinate you have to give. $54. Okay, that is 54. Right. Okay, 1 minute now. I will tell you it later. Okay, now this is parabola 0 to 81. Okay, base length is there. Okay, start. Fast start. I will tell once again. See, fast. Now I will not write something for some time. I will only explain now. Momentarian method. Theta max is theta A. Apply the first theorem from A to B. Theta A minus theta B equal to area of the BM by EI diagram between A and B equal to, if I divide like this, 1.2 into 60, half into 1.2 into 36, then 1.8 into 96 plus half into 1.8 into 54 plus 1/3 of 1.8 into 81. Calculate and tell the answer. Answer. Fast answer. That is the answer. 1.2 into 60, half into 1.2 into 36 plus 1.8 into 96 plus half into 1.8 into 54 plus 1/3 of 1.81. This more division because we can correctly do at A and C. If C is not required, then this black will change over to what? See, if by chance what? If the point C is not coming, then what you can get? Directly 3 into 60 plus half into 3 into 90. That also clear? See, if that point C is not required, then 60, total 150 means what? 90. This value will change over to just what? How much it is? 3 into 60 plus half into 3 into 90 plus this value extra. Answer. How much answer? Answer fast. Make a note. This is more division because I want to apply very clearly conjugate beam method. Actually, if the purpose is only theta A or deflection at A, you need not divide into 4 parts. You can divide only into 2 parts. Make a note there. For understanding, make a note. You can divide only in 2 parts. But later, when C comes, later I can't once again divide like this. To save the time, I am doing it. 363.6. 363.6. It is the answer. 363.6 by EI. See here. Therefore, your theta A equal to 363.6 by EI radian. How is it? Anti-clockwise. See the answer here? Correctly tallying. Okay. Now, deflection at A, maximum deflection. Deflection at A is nothing but what? Y of A with respect to tangent at B. Moment of the area of the BM by EI diagram between A and B, moment about A equal to, see, start. Moment about A, see, moment is about A. Therefore, what is the answer? 1.2 into 60 into half of 1.2 plus half into 1.2 into 36 into 2/3 of 1.2 plus 1.8 into 96 into 1.2 plus half of 1.8 plus half into 1.8 into 54 into 1.2 plus 2/3 of 1.8. Lastly, 1/3 of base is 1.8, height is 81 into 1.2 plus 3/4 of 1.8. That is the answer. Tell this answer. Sufficient. I need not explain further why. These all already over. Now remember, make a note. Suppose the letter C is not coming, then directly what? You need not divide into 4 parts. Then directly 3 into 60 into 3 by 2 plus half into 3 into 90 into 2/3 of 3. If this division is not there, but I made division because I need understanding. More figure means understanding more. But make a note. If A only required, you don't have to divide into 4 parts. Divide into only 2 parts. No, somebody may tell tomorrow, see, for finding deflection at A, he is unnecessarily dividing into 4 parts. I will tell, come and see what I told in the class. Do you think I am not knowing that much? It answer. Correct agi. E number. Then conjugate the method. Once this is over, that is deflection at A. 663.93. 663.93 by EI. Therefore, deflection at A equal to Y max equal to 663.93 by EI meter down. Okay, that also over. Correctly tallying. See, now, slope and deflection at C required. Then, to get slope at C, first theorem from C to B. Theta C minus theta B equal to area from C to B. How much area? 1.8 into 96 plus half into 1.8 into 54 plus 1/3 of 1.8 into 81. Answer. Illide. Answer. Only that side area. Only that side area. More division, actually with respect to A, only 2 divisions required. But you write there, you divide into more parts, grip will come more. But if by chance your purpose is only A, then division is lesser. I will not tell once again. Answer. Slope at C. It to slope at C. It is beka. Slope at C. ఈరోజు మూడు పార్ట్ అష్టే 1.8 into 96, half into 1.8 into 54, plus 1/3 of 1.8 into 81. Eto 270 by EI. Okay. Theta B is 0 equal to 270 by EI. Therefore, slope at C is 270 by EI radian is tallied. Perfectly correct. Lastly, deflection at C. Find y of C with respect to tangent at B. So your deflection at C is y of C with respect to B. Moment of the area of the BM by EI diagram between C and B about this point. How much? 1.8 into 9. Moment about this point now. 1.8 into 96 into 1.8 by 2. Half into 1.8 into 54 into 2/3 of 1.8. 1/3 of 1.8 into 81 into 3/4 of 1.8. Tell me the last answer I wrote there. Then I will go to conjugate beam method and close the method today for cantilever. So that now onwards, any question on conjugate you can solve by in the same way as Momentarian, but statement will change. Last answer. Your earlier answer is 279.45. What is the answer now? If it is same answer, confirm now. I won't use my trick now. If I use my trick, what is the advantage? That answer. See, in the class today, we applied shortcut, we applied Momentarian, and also we are solving by conjugate method. So there is complete coverage. Answer. Taking lot of time. This much time. Uh, 279.45. Okay. Equal to 279.45 by EI. Therefore, deflection C. Same answer we got earlier. Okay. Now, Momentarian method answer correctly tallied with our shortcut. If it tallies the shortcut, it will tally with the actual answer or what answer I can give with the direct shortcut, not the shortcut, further shortcut. Okay, over. Now, right, lastly, consider our main purpose. Main purpose is we are actually in conjugate beam method. These all we have done recap. These all recap we have done. Okay, now come to conjugate beam method. This is the real beam. Start fresh now. This is the real beam. This is the BMD for real beam. For what? For point load and couple. BMD for real beam. Considering UDL. I have shown all the calculation. Okay, now next step. Okay, space problem is there. I will manage here. No problem. I will manage here one by one. This space is sufficient for me. This is better. Now, separately draw. I told the reason. Start. Draw BM by EI diagram. At that time, see, 1 minute. Correctly observe. In case your I am actually telling 10th time today. Suppose your purpose is only to find slope and deflection at A, then you require this full BMD. Then tell me, this diagram you are divided into how many parts? Only 2 parts. Clear? This diagram you divide only into 2 parts. Don't waste 4 parts. I am dividing 4 parts because I want to consider C also. And also by dividing more parts, you are getting more grip. That's all. Clear now? Only two parts you have to divide. If your purpose is slope and deflection at C, at free and A, clear? Then the point C will not come. Clear or not? Divide that trapezium into just a rectangle and triangle. Clear or not? That way 4 divisions are not required. But if I do that way, later when you come here, again you have to make one more division. To save time, what I am doing? I am now only making easy for both the points. Clear? Okay. Now, start. Here. This is 60. A rectangle of 60. Rectangle of 60 by EI. I will write here now. Then here, the rectangle. Another triangle here. Then here, it will go like this. This I will divide what? I will divide like this. So, if I write all the values here, distance is there. This is 60 by EI. 60 by EI. This is, you can see there only, 36 by EI. And this all I explained for you. This is 96 by EI. And this extra is 54 by EI. And bending moment negative means load is upward. Load is upward. This all I told you. Load is upward. Okay. This is your BM by EI diagram. You write here. This is BM by EI diagram. Then one more diagram will come here. This way, it is red color I want. Why? Because it is parabola. I want red color for that one. Red color. I put red color so that it is a parabolic property. Okay. Red color, circle, red color. That ordinate is 81 by EI. Again, negative means upward. This is the BM by EI diagram. Below right, conjugate beam. Blue color, not required. Any color will do today. Okay, blue only I will write. When I don't want red, multiple reds. I am getting, see, 3-4 reds I am getting. When red is not required. Leave it. Okay, below. This is blank. Okay, not see. This is the conjugate beam. Now, free end in real beam will become fixed end in conjugate beam. And fixed end in conjugate beam will become free end in real beam. Fully clear? Free end in real beam will become fixed end in conjugate beam. Fixed end in real beam becomes free end in conjugate beam. Clear? Clear? Okay. Now, start. Distance point of view, just to understand, right here, this is 1.2 meter, this is 1.8 meter. Circle. A, this is B, this is C. Right. Here. These all I will remove. I do not want to, I want space here now. I will remove this one. And this also I will remove. I will shift this side. This is 54 by EI. This is 96 by EI. Okay. Right. Now start. Don't see anything now. Theta max, you know, is theta at free end of real beam. That is, theta max is theta A for real beam. Start. Theta A for real beam equal to shear force at A for conjugate beam, left up positive, right down positive, equal to, see, slope at A in real beam equal to what? Slope at A equal to shear force at A in conjugate beam. In conjugate beam, it's a cantilever fixed at A. Tell me, look free hand side. Look free hand side. What you can see? All these loads. Remember, shear force sign. Left up is positive, right down is positive. Since right side all up, it will be negative. all negative. Clear? That's why see theta will come anti-clockwise. All negative. Start outside. This 1 by 1, this area, how much? This load 1.2 into 60 by EI plus triangle half into 1.2 into 36 by EI plus this rectangle 1.8 into 96 by EI plus how much? Half. I think I forgot one thing here. Here every time you have divide by EI. I forgot tell. See every calculation momentaria, you know it. Divide by EI is there. Okay. Plus half into what? Half into 1.8 into 54 by EI. 54 by EI plus this area is the formula, parabolic area. Area bounded by a parabola. That is what? That is 1 by 3 of 1.8 into 81 by EI. Now tell me, is the theta A calculation for conjugate beam is exactly same as the calculation of theta A for Momentarian method? See there. Tell me, is the theta A numerical side, calculation part of theta A for conjugate beam exactly same as Momentarian method? Same. Only change is here minus is there because Momentarian method you don't put minus, you write directly theta is anti-clockwise. In conjugate, theta is clockwise positive. That's why minus came. Clear? Equal to minus what? Don't calculate. 363.6 by EI. Therefore, your theta A equal to 363.6 by EI radian anti-clockwise equal to theta max. Yes, that is the answer. Okay, now start. Deflection at maximum. Y max is Y at free end. At free end. That is Y at A for real beam. Start. Y at A down for real beam equal to bending moment at A for conjugate beam sagging positive equal to start. Deflection here is bending moment here, fixed end here. Look this side. Moment of the entire loading about A. Start one by one. Moment about A. 1.2 into 60 by EI, all positive. Why? Sagging, all positive. 1.2 into, outside you can plus. 1.2 into 60 by EI is the total load into moment about A, half of 1.2, or you can tell what? 1.2 by 2 if you want. 1.2 by 2 plus this triangle, half into 1.2 into 36 by EI is next load into moment about A is 2/3 of 1.2 further plus moment of this rectangle 1.8 into 96 by EI into moment about A 1.2 plus another half of 1.8 by 2 plus one triangle half into 1.8 into 54 by EI is that one into CG is somewhere here. So 1.2 plus 2 by 3 of 1.8 lastly plus that parabolic part. How much? 1/3 of 1.8 into 81 by EI is the load into its CG is here moment about A 1.2 plus from here to here is 3/4 of 1.8 over. Now tell me, is the calculation of Y max for conjugate beam YA is exact duplicate of calculation of deflection at A by Momentarian method? Tell me. exact replica of calculation of deflection at A by Momentarian method? Is it exact replica with no change, nothing? First, exactly same as that by Momentarian method. Tell yes or no. Not answered. Exactly same as by Momentarian method. No change. Therefore, why should you waste time? Answer is alley ide plus 663.93 by EI. Therefore, deflection at A equal to 663.93 by EI meter down. That itself is Y maximum. Okay. Now lastly, you have to find your theta C and YC. Okay, I will do one thing now. One thing I will do. You do not see that side. Do not see that side. You take your paper and write correctly. Do not see that side. Once you complete the writing, compare, is that calculation same as this calculation and this calculation? If yes means stop, then over. Okay, 1 minute. I will tell what statement you have to write. See correctly. I will tell what statement you have to write here. That's all. Then you write. Okay, start, buddy. Now, next. Theta C and YC. No, theta C clockwise in real beam equal to shear force at C conjugate beam. You write, this is gone. You write what is the calculation here. It should come same as that one. Therefore, some answer will come minus 270 point by EI will come. So theta C equal to 270 by EI radian anti-clockwise. Then Y, then next you require what? YC. Next. YC down for real beam equal to BM at C for conjugate beam. Not here. BM at C for conjugate beam. Look this side. Last time when you do BM at A, 1, 2, 3, 4, 5. Now BM at C, only 1, 2, 3. These two are not there. Last time moment about A, now moment about C. You write here calculation. I'll remove this one. You write the calculation and calculate if you want. Or you should see that calculation is ditto duplicate of that value. Then without seeing anywhere, you can write plus 279.4 by EI. Over. Can you try now? I'll take a small break. Can you freely try without seeing that one? See only conjugate beam method, write shear force at C, write BM at C, looking free hand side. It should tally with what I wrote there. Those who come live, if they understand, my responsibility is over. My responsibility over only if I convince those who are live. That's all. Others I don't have to convince. Yes, okay. Write fast. I'll come in 2-3 minutes. I'll give an extra question for you. No. And we'll close the cantilever. Okay. Got the value? Okay, then I won't write because I will dictate here. Those who are serious later, they will write themselves only. See, I will only dictate here. Deflection slope here is shear force here. Look this side. Right up is negative. Negative of 1.8 into 96, half into 1.8 into 54, 1/3 of 1.8 into 81. Over. You get the answer. Deflection here is bending moment here. Look this side. 1.8 into 96 into 1.8 by 2 plus half of 1.8 into 54 into 2/3 of 1.8 plus 1/3 of 1.8 into 81 into 3/4 of 1.8. If you got the answer, I don't have to ask you clear or not. Why? When you told answer tallying, if it is not clear, how it will tally for you? Okay, over. Now, little time is there. I will give one question. Can you try here only get the answer? I will directly give the question with the answer. I will start the conjugate beam method, prepare the conjugate beam and stop. Can you try here? I will give direct answer. That later you can solve by Momentarian method. See, yesterday also, one question I solved for conjugate beam method. Second question, you can try because still around 20 minutes is there. Instead of closing the class, one extra question. I will give change of EI. I will start the question and give answer and walk out. Walk out means what? I will go that side. When you type, you got the answer, I will close the class. Will you try? When you type the result, yes, got the answer, I will close the class. If you are trying, tell me. Right now. Okay. See. I will not give explanation. Cantilever beam with change of EI. Okay. A point load of 60 kilonewton. This is equal distances. This is 3 meter. This also 3 meter. Over. This is EI. This is 2EI. A, B, C. Later you solve a Momentarian method. Okay. Find only theta max and y max. Over. Draw the bending moment diagram. This is the real beam. 0 here. Here 60 into 6. R only 36. 360. It is a straight line. Okay. But unfortunately, this is the BMD for real beam. Minus. If the change of EI is not there, this is not a question. Just one triangle. Correct? Clear? If change of EI is not there, it is a triangle over question. Why should I do it? Answer is WL square by 2 and WL cube by 3. But because of change of EI, you need this value. What is that value? 60 into 3, that value is 180. Okay, 180. Now, when you draw BM by EI diagram, 0 here, it is 180 by EI. It will come like this. This is 180 by EI. Then, when the same point, and when you come here, it is 360, and when you go that side, it is 180 by 2 EI. So, it will become 90 by EI. And here, it is what? 360 by 2 EI. That will become once again 180 by EI. It will come this way. This is your BM by EI diagram. Now, what you do is, this full is 180, or you can modify the diagram. One triangle here, one rectangle here, one more triangle here. This is total, how much? 180 is there. This is 90 by EI. This ordinate is 90 by EI. This also becomes 90 by EI. This full height is how much? 180 by EI. 180 by negative, therefore everything is upward. This is your conjugate beam. Conjugate beam. Now, slope at A in real beam equal to shear force. This is your theta max. Shear force at A in conjugate beam. Get the answer. Deflection at A, that is nothing but your Y maximum in real beam downward equal to BM at A in conjugate beam. Calculate. I will give the answer and walk out. Okay. I will tell you here now. Slope here is shear force here. This full loading. Deflection here is bending moment here. Will you try? I will give the answer and walk out. Then you type, got the answer. If you typing and got the answer, I will come back and close the class without informing. You will try? I will give direct answer. Actually, by this time, you would have got one answer. Okay, no. Both are 3 meters. But I will not use this one. $675 by EI. $2430 by EI. That's all. You get these two answers. If you got these two, just type got both the answer. I will come back and close the class. Tomorrow I will tell you how to apply conjugate beam method for overhanging beam. Some important information is there regarding internal hinge. I wrote the answer. See, you got slope correctly. If you get depression correctly, you write the answer. I will come and close the class. I get 10 minutes extra break before the next class. Advantage for me. Little rest I will get. Tomorrow I am doing last class on conjugate beam method. That is for overhanging beam. Remember, some extra concept is there. Overhanging beam. Free end become fixed end. Simple support becomes simple support. That overhanging support becomes internal hinge. I will tell those things tomorrow. And tomorrow I will close. Day of tomorrow, that is next week, new chapter. Most probably columns. The theory of Euler's buckling load, Rankine's failure load, different versions of column theory. Next class. Okay. Start. I will wait. Got the answer? So instead of going and coming back, shall I close and go back? If you got both the answer, why should I go and come back here and leave unnecessary class open? Shall I close? Then why should I wait? Or conjugate beam method for cantilever also. Completely crystal clear now, without any doubt. Correct principle and calculation. Conjugate beam. Crystal clear? Okay, thank you.